Alright, so in this video we're going to be looking at Bernoulli equations. So a Bernoulli equation is in the form, let me change that size. So a Bernoulli equation is in the form of a of x times y prime plus b of x times y is equal to c of x times y to the alpha. Where a is non-zero. But now note, if alpha is 0 or 1, the equation is linear. Thus, we're going to assume that alpha does not equal 0 or 1. So the key idea, the idea of a Bernoulli equation, the idea is to introduce a substitution where v is equal to y to the 1 minus alpha. And this allows us to transform the equation into a linear equation. So this is a substitution. Did I spell that right? Yeah. T-I-O-N. Okay. Okay, so let's look at example 1. So for example 1, we have x times y prime plus y is equal to x squared y squared. So off the bat, looking at our form here, let me zoom out. Looking at the form, our alpha is 2, right? Now we can see that it's not 0 or 1, so that tells us that we have to use the method for a Bernoulli's equation with the substitution, right? So we know alpha is equal to 2. So then we can do our substitution. V is equal to y to the 1 minus alpha, which is 2. So then v is equal to y to the negative 1, right? But now we also need v prime. So we're going to use chain rule for v prime. So v prime, so you pull down the negative, this becomes y to the negative 2, and you multiply it by the derivative of the inside. Excuse me. Which is just going to be y prime, right? Because derivative of y is y prime. So now that's v prime. We have v prime. This is v, here's v prime. Now we could continue. So now, to start off with, we want this term by itself here. So we're going to divide the whole thing by y squared. So this is going to become x over y squared times y prime plus y over y squared is equal to x squared. And this simplifies to x over y squared, y prime, plus 1 over y, or y to the negative 1, right, is equal to x squared. So now, we want to rewrite, see, the reason why we divided everything by y squared is because we want to rewrite everything in terms of v. So if you look at this equation right here, this is v, right? Because v is equal to y to the negative 1. And you all can also see here that we have negative y to the negative 2 times y prime is v prime. So if we look over here at our first term here, this is basically can be written as this, right? That should be negative 2. That's a prime. So then this is the same thing as v prime, but it's the opposite sign. So all we're going to do here, when we rewrite this, we're just going to rewrite this as negative v prime, because v prime is negative up here. So now we have this, and don't forget the x that was there as well, times x plus v is equal to x squared. Now we can get rid of this first x up here by dividing everything by x. So minus v prime plus v over x is equal to x. And now you see the formula on the right side here. We have either whatever your book calls it, g of t or q of t, whatever. But this is our q of t. Oh, I use g of t in my other videos. This is our a of t, our b of t. So because we have this g of t term here, we have to do integrating factors, right? So let's see what our mu is. Sorry, this is of x this time. Yeah. So g of x. Our mu of x would be e to the integral of our p of t, right? Our p of t is equal to 1 over x. So then our mu of x is equal to e to the integral of 1. Oh, wait a minute. You also, when you divide by x, you should also divide by the negative that's in front here. So then all these other terms here would become negative. Yeah, you should definitely get rid of the negative on the first term. So then this is actually, our p of t is actually negative 1 over x. So then this would be negative 1 over x dx. So then our mu of x is equal to e to the negative natural log of x. And remember, that constant, when we do integrating factors, we assume it's a non-zero, so we can assume it's just 1. So the constant disappears, right? If you need help with that, just go back to my first video in this playlist. Okay, so now we have our mu. Remember, we solve it by it's mu times v, right? Because this is in terms of v. So mu, which is e to the negative natural log of x, times. Also, I just noticed something. I just noticed the mistake I made up here. That's of x. Okay. Times v is equal to, remember, it's the integral of mu times g of x, right? So we're going to have a negative in here, negative x, e to the natural log of x. Right? Yes. Okay, but now I just noticed something as well. We can simplify these e to the negative ln x, because we know by the log rules, whenever you exponentiate a log, it just becomes whatever is on the inside of the log. But we have that negative out front there. Oh, this should be a negative here. We have that negative out front there, so that's e to the natural log of the inverse of x, or 1 over x, times v is equal to the integral negative x e to the natural log 1 over x. That can become just 1 over x times v, right? Times the integral negative x times 1 over x. And guess what? Those cancel. So then that's just v over x is equal to the integral of negative 1 dx. So that's going to become v over x is equal to the integral, sorry, I'm going to integrate now, negative x plus c. If we multiply both sides by x, we're left with v is equal to negative x squared plus c times x. And then we have our solution when it's in terms of v. But remember, when we started the problem, it was in terms of y, right? We have y prime and a y. That's a first order differential equation in terms of y. So we have to go back. What was v equal to? The inverse of y, right? V is equal to the inverse of y. Now, you can write it like this, or you can just write it like this. Right? Both the same thing. Alright, so now let's look at the next example. So in the next example, we have x times y prime plus y is equal to y to the negative 2. So for this one, our alpha is negative 2. So then our v is y to the, what was it, 1 minus alpha, right? Yep, y to the 1 minus alpha. So then v is equal to y cubed. V prime would be equal to 3y squared times the derivative of the inside, y prime. So now, let's go back to our equation here. We're going to divide both sides by y to the negative 2, right? So we have xy prime plus y is equal to y to the negative 2. We're going to divide it by that so we can get our equation in terms of v. So we're going to be left with x over y to the negative 2 y prime plus y over y to the negative 2 is equal to 1. Now we can simplify this. This will become, this first term is x. This becomes x y squared y prime plus y cubed, right, is equal to 1. Now let's look back up here at our v's. So v is equal to y cubed. So this is v. And v prime is 3y squared times y prime. So we have that extra 3 there, right? So if we divide that by 3, that tells us that v prime over 3 is equal to y squared y squared times y prime. So then this would be replaced with x times v prime over 3 plus v is equal to 1. And now we got to get rid of the coefficient on the v prime term. So we're going to multiply everything by 3 and divide everything by x. So we have v prime plus 3 over x times v is equal to 3 over x. And now we're ready to use integrating factors, right? So our p of x, is 3 over x. And our g of x is 3 over x. So for our mu, it would be e to the integral of p of x, right? So that's 3 over x dx. So then our mu of x is e to the 3 times the natural log of x, right? And that is just equal to x cubed, right? Remember, the coefficient goes into the exponent of the inside of the log. So this will just become, and the exponent, whenever we exponentiate a log, it just becomes whatever on the inside. So we have x cubed. So now, remember the formula. So we have mu of x times v. So x cubed times v is equal to the integral of mu of x times g of x. So that's x cubed times 3 over x. Let's simplify this a little bit. This is 3x squared. The integral of that is x cubed plus c, right? Because that 3 cancels. And then we need to solve for v now, right? So v, if we divide everything by x cubed, we're left with 1 plus c over x cubed. So then this would become, I'm just going to rewrite it like this. So then, because we look back up here, what was v? V was y cubed, right? We'll be left with y cubed is equal to 1 plus c x to the negative 3. And that's our answer. So this is the answer to this problem. So basically, we know it's in a Bernoulli form. Whenever we see on the right side, we have y to the negative 2, right? That's an immediate given that this is a Bernoulli's. And if it's a 1 or 0, then it's not, because if it was just a 1 or 0, we would just have y or 1, right? It wouldn't be right? Because then it would be linear. So in this case, we have this. It's not linear. We're turning it into linear by using this v substitution that we have with this alpha. So then we go through the whole substitution. We turn it into a linear equation. We then are able to use integrating factors to solve the linear first order ordinary differential equation now, just in terms of v. And then we go back at the end and we plug whatever v was back into it to get it back in terms of our y. And that's the answer to this problem. All right, in the next video, we're going to look at the existence and uniqueness theorem for first order ordinary differential equations. Hope you enjoyed the video.